Hello everybody. So here we go again. I know today, it's still the Microsoft Build conference and everybody is hyped about what's happening there. There were already some big announcements and probably they'll continue today. I myself watched a lot of discussions and sessions and breakout sessions and workshops there. And I'm fairly impressed, I have to admit, but I still decided to keep going and continue with my social network, even if I have to compete with the Build conference. So today we'll continue from where we left off last time. I really didn't do anything else to the application. Let me take off my headset. I really don't need it right now. So today we'll just continue. I have to also find out exactly where we left off. So we started to work on our first bounded context. It was the user aggregate and it was in the social bounded context. The idea was that we started to work on this bounded context because this is where basically all the interactions between students and teacher will happen. And therefore this is the social bounded context. So I guess we'll just continue there. Just as a short recap, in the shared kernel we have created a bunch of base classes. It's first a base class for entity that we use to implement all our entities according to the domain driven design principles. Then we have the value object class, and this is our base class for all value objects that we will have in our application. And here I see that we actually don't need this using statement, so let's take it out. And then we have also another base class, and it's for enumerations, because I decided, or I think that it might be useful to use our custom enumeration class instead of the default enum that we have in .NET. And if you're interested why I made this choice, or why I think that it might be better to go this way, I have recorded a video on custom enumeration classes that I have put on my YouTube channel, so you can of course check it out. If you go to YouTube and search for this channel, you will find it, or maybe I will search for the link and just paste you the link right there. Sorry, just 1 second. Just 1 second, and there it is. That should be it. And actually there are a lot more videos right there, also for beginners, but I also started to create some new content for YouTube. So there might be some things that might need to, or that are not really worth a stream because they are shorter. That's a very specific topic. So for that case, I continue to record videos that I will then post to YouTube. So if you don't follow me on YouTube, you can do this, and in that case you'll keep up to date. Okay, you got a question: if it's possible, how can a class with a private constructor can be instantiated? I'm glad you asked this, and we will come to this today. Basically, the whole idea in domain-driven design principles is not to use the constructor to instantiate a new object of this type, but to use factory methods, static factory methods. And in fact, we will implement factory methods today for our user at least. But this is normally the way to go. And the idea behind this is that especially, or in case if you work maybe with subtypes that you want to keep private, similar to what we did in the custom enumeration class. If you watched the video on YouTube, then you can basically, in that factory method, you can just return a subtype, and the consumer of your class, it doesn't really care, or he doesn't really know, or it doesn't really need to know what type exactly do you use. But in the factory method, you can just return any subtype that might be suitable in certain scenarios. So we will be using factory methods. Now let's maybe try to get started, and let's go back to the user. So till now we have implemented a few properties. We have implemented the user type, which is our custom enumeration class, and we have implemented our custom enumeration class here. And we also implemented the name, and the name we have implemented as a value object, as we see. So this is why we have to also override this get atomic values in order to be able to check for value equality between different different objects of the same type. So what is a factory method? That's also a very good question. It's just a method that is used to return basically an instance of a certain type, and I guess it will be much easier once we get there. But before we get to the factory method, let's then continue. The next thing that I would like to implement is said our social network is aimed to be used in school, mostly in universities. So in this case, basically each user, either it is a student or a teacher, but it has to kind of belong to a certain faculty. And this is why I think that we should implement a property that that defines the faculty, or that holds the information about the faculty that the student or the teacher belongs to. So in that case, let's go to implement this class. Okay, it would be here in user aggregate. Let's add a new class, and this class, let's call it faculty. Let's also not do typos if possible. Let's make it public. And the question is here, what should this class actually be? Should this be an entity or should it be a value object? I guess, I don't know, my first hunch, it should be an entity because, well, we should be able to identify a certain faculty by ID. I see this as a class that should be entity. However, if we come to the conclusion later that this is maybe not suitable, then we can change that at any time. So there is no big problem with that. Let's also implement the shared kernel, or import the shared kernel, where we have defined our entity base type. And yeah, let's go further. Let's create the first region here. It would be, as I always do, it is constructors and properties. And here, let's have a constructor. We'll make it also private, as we did till now. Private faculty, and we also have to take in an ID which is of type GUID and pass it to the base class. And for now, I guess that should be it for the constructor. Now the faculty might have a name, which I guess it can be just a string. The name of the faculty, and it will be, as I always do here, with private set, so that we are not able to set the properties except only from inside of this class, because this is very important. Maybe each faculty should also have a description, which I guess it should also be of type string. Private set, of course. And yeah, what else should we have? I guess basically in each faculty there might be different departments, so I guess we should also model this into our domain, so that basically the department should actually belong to a certain faculty. But yeah, let's try to implement that. I guess for that one we would just need another object, or sorry, another class. And I guess that in this case let's call it a department. Let's make it public. Okay, and I think department is just basically, it will be just a name and a description. Let's for now make it a value object. Okay, And since we have a value object here, we have to implement this get atomic values, but we'll implement it actually just a little bit later. For now, let's also start here with the constructor, I guess. Let's end the region, and here it will be constructors and properties. But I will have also to type it correctly, properties. So yeah, it should be that way. Okay, and here we also need a constructor, and we'll also make it private. And by the way, I think here we'll already create a factory method for the department, and then basically we'll then continue to implement factory methods for all the other objects. So for the department, since it is a value object, I don't think that we necessarily need something here to pass as an ID or something else. So the constructor we might even leave empty for now. Why we still need this constructor is that we probably well, I want to make it explicit first, and it can be used of course by entity framework core just a little bit later. And this department for now, let's have it. It should also have a name, private set, and it should also have a description. Okay, private set. All setters are really private here. Now, I think that one other thing that might be important, but no, for the department, I guess that's basically it right now. Okay, so let's see if there are any other questions for now. No other question. So yeah, let's continue with this idea of department. So right now, what I would like to do is, for instance, to create a department. And if I want to create a department, for this I would expose some factory methods or factories. Sorry, it should be region here. Okay, and the factory method, they said, is just a static method that returns an object of this type. So it would be a public static, it will return a department. And it will be called create. What we'll need here would be, as an incoming parameter, it will be a string name and the string description. And here, as it is everything very simple and straightforward. Right now we won't do any validations. We can just also use the constructor to take in those name, string, description. Okay, and here in this case we'll set the name would be name, and the description would be description. I guess that should be it. And here in this factory method, in this case we just will just return return new department, but I have to also of course type it correctly, and we'll pass in the name and the description. Okay, and you asked, basically this is a factory method, and the way that we would create an instance of the department wherever we are in code, we would simple say, let's make it as a comment, would say var department equals department.create. As said, the reason why factory methods are preferred in domain-driven design is, first of all, because in the factory method, then you can perform different type of validations, maybe use different services that will do the validation. So you might need to put a lot of logic here in this factory, and it wouldn't be very useful to put a lot of logic in the constructor of the class itself. So that's why that's one reason why we usually use factory methods. And then the other reason is that, as said, maybe in our application we decide that we have a different type of departments. Like we could have, I don't know, maybe a study department, but we could have like a department of the university, like, I don't know, finance or legal or something like that. And if we need to distinguish between this type of departments, this type of difference between department times is something that is actually belonging to this whole idea of department. So in our social class, or in our user class, or whatever other class that we have in this bounded context, we don't really care what type of departments there are. This is the internal logic of the department itself. So we could basically create here a subtype, like subtypes like private class. And here would be, I don't know, history department. And we can also leave it blank, but it's totally private. Let's maybe make it to make sure that this is a department. Let's make it inherit the department itself. And in this case, would have, of course, to take in a string and a name in the constructor, sorry, a name in the description, and pass it then to the base class. String name, string description, and we will pass this to the base. Sorry, base name description. Okay, and now theoretically, here in this factory method, if I don't know, based on certain criteria or validation logic, whatever we implement, instead of returning a department here, we can just return a history department. Once again, this is important for this department itself, but for the consumer of this class, it really doesn't matter that basically behind it is a history department. And the reason why we might want to use this type of classes, this type of subtypes, is because each class is basically a container for behavior. So if we have behavior that is specific only for a certain department, like this history department, we can simply add this behavior to the history department. And then basically each time that a consumer would create a new department and would receive a history department, it would get also the specific behavior that is associated with this specific department without exactly knowing anything about it. So this is basically full encapsulation. So encapsulation at its finest, I would say. So this is mostly the reasons why we use this, or why these factory methods are preferred. But let's now delete this history department. And yeah, I guess right now it should be okay. So is it clear right now why we prefer these factory methods instead of the constructor? Or are there any further questions on this? Okay, good. Actually, yes, sure. I have to confess that basically after I have started to well, study and to try to understand everything about domain-driven design, the idea of using factories is something that I then basically went to implement in almost each class that I write, even if I don't necessarily follow the domain-driven design principles in that specific project, because I think that it is a good idea. It really gives you a lot of flexibility to play around with subtypes if needed, and for me this is really very important. So this is one of the things that I have learned from domain-driven design, and that I really use also when I'm writing code that is actually not following these patterns. So yeah, let's we have also to implement, of course, this get atomic values in order to be able to perform value equality check. And here we would simply have to yield return the name and yield return the description, and that should be it. And for right now, I guess that for the department actually we are fine. So if we go back to this faculty, we would have another property that would be public. I would have to also type correctly public department. The name of the property would also be department. and that's it. Now let's think further. What do we maybe need for a certain faculty besides the department itself? I guess to the faculty, actually a faculty can have several departments. So yeah, so in this case basically this property just wouldn't be a department, but it would be something like a list of department. And actually that's really great, because right now we get into a different problem that we have to take into consideration. So let's think about the following scenario. We have this property which has right now a private setter, and let's use some comments just to make sure, or to outline what I mean. So this property right now, departments, let's also pluralize it. It's for sure a private set, so nobody outside of this faculty class would be able to set this property or to assign basically a new list of department to it. However, what it would be possible to do outside of this class is say, for instance, var faculty equals new faculty, in the idea that we will use the constructor. So this is again code that we can write outside of this class. And even if this property departments has a private setter, what we cannot do, so this is not possible if we would do faculty dot departments equals new list of department. So this would not be possible. This would not be possible. Very, very important. But I could still do, again, from outside of this department class, I could do departments add department. And the problem here is that the entire logic, or this class, this faculty class, since it is an entity, it should basically make sure that the objects that are instantiated of this type are always in a consistent state. Now here, when we can, from outside of this class, if we can add departments to the list of departments, this could bring some problems, because this could put the entire object into a state that is not valid. And this is a really big problem and a very big concern, especially when we follow domain-driven design, because we shouldn't be able to add departments to this list of departments. The domain-driven design way to do this would be to just expose a method that would be public. It would return actually void. It doesn't need to return anything, and it would say add the department. And here in this method, I would take in a new department. And here I can then add the department to the list, but after I check if with this department my object will still remain in a valid state. So this should be the only possible way to add a department to this list of departments. So we have to think about a way to achieve this, or to really lock this, so that nobody is really able to do anything here. I see here a question I've heard about the atomic term in programming, but I am not sure what does it stand for. Well, it really means basically all the parts that compose a certain class or a certain objects. In our scenario, we just mean the properties, and these properties are the values based on which we will compare, or based on which we'll do the equality check. But the fact that I named this method get atomic values, I was just inspired by others that did the same thing. We could actually the same way have named our method get properties, get object properties, or something like that. So it's not something that we really needed to name this method like that. It's just something that is generally used when you want to basically go or iterate through all the properties or attributes of a certain object and get the values of them. And in our case, we want to do that in order to be able to compare them and then see if two objects are equal or not. So this is basically what that method does. Okay, But coming back to this idea of list of departments. Sorry. So I guess that a very easy way to do that is, instead having this property as a list, we define it as an IEnumerable. Now the advantage of defining this as an IEnumerable, the add method is not there anymore. So right now consumers outside of this class are not able to actually write this faculty departments add. So this won't be possible anymore. So the first part of this problem we have solved, but still what we need is something to really hold a certain list of departments that can be then modified, maybe using this add department method. We could also have a remove department method, because we have to be able to add departments to that list. The only important thing is that that process is done within this class, so that we are able to enforce invariance across this type of entity. So what we can do here, instead of just using a list, we can introduce a new field that would be a private field, and this field would be then of type list of department and departments. We don't really need to give a value right now, and we'll see also why. And then we have to change this property just a little bit, and instead of using auto implemented properties, we can just implement a getter that returns this private field. So basically it's exactly the same thing that we would need to do maybe in Java, where I don't think that we have auto implemented properties. But the advantage is that this field is right now private, and what I could do here is, of course, after I perform certain validation, right now I won't do a validation, but theoretically after I perform validation, so after validation, what I could do, I could say departments dot add, and then just add this new department. And once again, in this case, the advantage is that the logic or the validation, or within this faculty class, I am able to make sure that this class, or to give a guarantee that this class would always be in a consistent state, because nobody from outside can basically add departments to my list. I am the only one, so this class is right now the only one that can manipulate this list of departments, and we don't really need a setter here at all, because well, once we have this this field, then basically we return it every time, and then we can also perform different actions on this. For instance, we can also say public void remove department. And I don't know, here I maybe say I want to remove a certain department. I would have to get this specified as an incoming parameter, and then I could say once again after validation, I would simply do departments dot remove, and then remove this department from the list. Of course, first I can search the list to make sure that this department is really there, and not necessarily try to remove a department that is not even in that list. But as said, right now I don't want to concentrate on this type of validation. I just want to have a very basic layout of this domain model. And then basically we will probably come to different conclusions that we still have to add different functionalities, different behavior to our aggregates, and then we'll be able to define exactly, okay, what do we actually need there, which are really the invariants that we have to enforce in this aggregate, and then also then we will do the validation. But for now, I guess that this solves the problem. So right now we have here basically a list of departments that we will well use a factory method to get, and then basically we assign it, or we get it via this private field. So in this case, nobody from outside would be able to manipulate this list. So it won't be able to add objects to the list or to remove objects from that list. Just a second to see if there is any other question. No, I don't see a question right now. So yeah, let's then continue. So we have implemented this faculty entity. What we still need is, of course, we can delete this. I just wanted to showcase what the problem is in this case. However, we should be able to create a faculty, and in this case, let's go further. So region factories, and the reason why I name this factories, so why I pluralize it, is because we could have different factory methods, like different overloads for a factory method. Right now we just implemented, or for the department we just implemented one factory, and I guess I will implement also one factory for this, but generally we can also overload the factories. So here we would have, it would be then a public static, it would return a faculty. Sorry, it's not get set into, it would be create. Okay, and let's see a little bit what do we need here to create a faculty. So we would need a name, we would need a description, and we would need probably an IEnumerable of departments. So let's make it, let's then have here as an incoming parameter, we have the name, we have the description, and then we can also use default properties. So these are properties that can have default method parameters, and those are parameters that can have basically a default null value. And let's make it here an IEnumerable of department, and it will be departments, but then we can see the default is null. So in this case, this means that whenever we will call this method, we are not necessarily obliged to also provide a parameter for departments. If we don't have any departments for a certain faculty, then we cannot provide them. So in this case, using this as a default incoming parameter with a default value of null means that basically anybody, or in each class where we want to consume this factory method, we are not obliged, so we don't need to necessarily provide also these departments as an incoming parameter. Now what I can do here is, for instance, and the string and the name right now I don't, or the name and the description I don't really want to validate. So in this case, we can just provide them in the constructor, string name, string description, and here I can say then name equals name, and then the description equals the description that we get in the constructor. And here it is another part of how I usually use factory methods, is that, okay, for instance, for those properties that right now I really don't want to validate, I can then pass them in the constructor. But then with this IEnumerable of departments, I might want to do some validation, some basic validation even now, to define if that department is really null or not, and if it is null, what to do. And in this case, we can just simply do the following. We can say here var department equals new department, and we provide the name and the description. And then we can simply go ahead and do the following: department, and then we will use this, but it's department, sorry, I have a typo here, so it's it should be like that, and it would be then department dot And since I am in this class, I would have I should have, but why don't it's a list? Okay, it's a departments. Okay, yeah, it's there. Let's try to see further. So departments would be equal to and I say if departments, so it should be equal to departments, but if departments are null, I would say that it would be a new list of department. So basically I would create an empty list if the incoming parameter is null. So yeah, in this case, let's just see what happens here. Why do I have these errors? And we will also return the department afterwards. Okay, so let's see what do we have here. So here we say that cannot implement for type. Okay, because here it would be departments to list, because we have to change this to be a list, but it still does not contain a definition for departments and no access. But then I guess I have a typo somewhere. It's departments. What am I missing here? What am I missing here? Because here is also the new department. It's something that is not okay. Let me check. It only says that can be simplified, but I'm not in department. Oh my god, I'm not in department. I'm in faculty. I create a faculty right now. Why don't you tell me? I create a faculty, not a department. I'm done with with departments. I just need to create a faculty. But it still has the problem. There is no argument given that corresponds to the required parameter description in the faculty. Okay, of course we have to provide also the ID. Okay, GUID ID. So this is also something that we need, and in this case let me bring this on a different line. And here we would have to specify then also, of course, ID is in the constructor, so we also have to specify it here. Yeah, I guess that that should do it for now. But here it should be like that. So with this one we are done, and here of course we don't have a department, but we have a faculty. And of course in this faculty we have departments, and then if the list is not null, then we simply add it to that field. But if the list is null, so if this incoming parameter has the default value that we have specified here, so if the caller didn't basically provide a list or an enumerable of departments, then it will be null, and in this case we'll just create a new list of department. It will be empty, but we'll still assign it here to the departments field. The reason why we do this is because if we assign the null, the incoming null, then our methods that would try to add a department or remove a department would basically fail. So in that case, what we want to make sure is that in this factory we just simply assign an empty list if we don't have any known department for this faculty, and then of course we have to return the faculty. And I guess that right now that should do it. It seems that we don't have any errors anymore. So this is right now our factory method, which is fairly cool. And then we have to implement, let's also put this in a region. It would be a public method. We could even name it behavior, because in domain-driven design everything should be about behavior. Let's close this region. And right now I guess that we have our faculty. So we can go back to the user. How about edit department? Of course, yeah, that is something that we can add. Let's do that actually, if you say. So I guess we would need to have an option to edit both department, but also the faculty. So yeah, the idea is that we can simply do that. Let's region, how can we name this? Base class overrides. Let's close this region here, and then let's add a different region after the factories, which would be public methods. Okay, that should be fine. So you said about edit department. We have here a public. We will return a new department, and it will say edit department. But what do we really want to do when we edit a department? Because we can either change the name, we can either change the description, or maybe change them both at one time. So in this case, we can just simply have a change department name as a method name, and here we will take in a parameter that would be of type string. It would be the new name, and then what we would need to do is simply go to name and assign basically this new value, new name, of course. Here once again, at a certain point, we will add some validation, because maybe we want to enforce some invariants about a department name, things like that. It should be longer than, I don't know, 3 characters, less than 50 characters, whatever. This type of things we would then add for validation, and we'll probably create some custom validators for each of our types or specifications. That's something that I still think about, so it's not really decided. But in this case, I want to come back to another point and ask you, is this way to proceed correct from a domain-driven design perspective? So what would you say? So we have this change department name method that takes in a new name, and it simply assigns the new name to the name property of the department. The department, once again, in this case, is a value object. So my question is, according to domain-driven design principles that I have talked about in the first episode, is this the correct approach to proceed, or should we do this differently? Let's see. What's your opinion on that? No opinion? Was my question clear enough, maybe? And you say, I guess it is. Okay, and why? Can you maybe also give a reason for that? Okay, change the name does not make an impact. Yes, that is correct. But when we talked about value objects, I said there, or actually it's not me that I said that. It's already started with Eric Evans, who wrote the first domain-driven design book and basically coined the term. But the idea of value objects is that they should be immutable. They should behave like strings. So if you think about the string in C#, if you create a new string, so basically like that, string, I don't know, name. So if you create a new string, and then maybe you you go and do something like name equals, and then you put there something else, I don't know, John, let's say. Basically what it happens, it's that it doesn't modify this string, it basically creates a different string. And this is exactly the type of behavior that we should implement in value objects. So value objects should be immutable. The whole idea of value object is that they are just a pair of properties and nothing else. We don't really care about anything else. So in this case, according to the domain-driven design principles, what we would need to return is basically a new value object, and then we would do return department dot create, and we will use the factory. We will provide the new name in this case. We will provide the new name, and we will provide the old description, so the property. And in this case, we would just return a new instance of department. And of course here, as we are in the same method, we can just simply use the create without specifying the department. But I guess you got the idea. So right now, by doing this, basically our department is immutable, and every time we want to change something about the department, what we actually do is we return a new object with the updated values. And that's basically according to the domain-driven design principles and practices. And then similarly, we would have a department. It would be change department description. We would take in a new string that would be the new description. And then of course we would, after validation, I just type this so that we get reminded that we would have to implement validation here, and we will simply return a new department by using the factory method. In this case, we provide the name as an incoming parameter or as an argument, and we provide then the new description. And then last but not least, another way to edit a department is public department. How should we name it? Modify. Maybe if you will change the ID, I'm not sure I get. Maybe if you will change the ID, would have. The idea of value objects is that they don't have IDs. So that's the whole point of value objects, and the main difference between value objects and entities. Value objects don't have IDs. They are not identified by an ID. They are just identified by a common bunch of values or properties that should always be the same. Like in this case, have a name and a description. But we don't have any IDs on value objects. This is a very, very important point of emphasis in domain-driven design. And here it would be modify or edit department. Let's name it edit department. And this edit department method would be then basically used to change the entire department. So in this case, we would need a new name, and we would need a string, and it would be new description. And then here, after validation, we will return create, and then we'll provide this updated value, so the updated name and the updated description. And that would cover the modifying departments. Then similarly, we could do the same things for the faculty. The only difference, and I guess maybe that's important to really do it, since this is an entity. In this case, modifying this entity means that we should just modify the property. So this is the very, very big difference between entities and value objects in domain-driven design. So after this factory methods, we have this add department, we have this remove department from the list, and then we could here also implement this behavior regarding the edit. So we have a public that returns faculty, and here it would be a change name. And here we would have a string that would represent a new name. And in this case, we can just say that name equals new name. So since this is an entity, we can really do that, and we don't actually need to return the faculty. We can just return void, or probably if we do validation, we'll just return an exception. Or better yet, we will just return a result of changing this department name. that if it failed will contain the error message. This is a way better pattern and practice to do to handle basically problems that come up in the application. Throwing exceptions everywhere is really not a best practice due to a lot of different reasons, but I guess I will come to that maybe at a certain point later, where we will implement a class something like operation result or something like that. So once again, in this case, we can just simply update the property because this is an entity, and entities are not really immutable. They can be changed. The only thing that we would have to take care of is that the invariants are kept. So this means that each change that we want to make should not put the object into an invalid state. And this is we will implement this type of checks just a little bit later when we have at least our first bounded context kind of like set up from the aggregates perspective. So then we would have similarly a public and it would also for now return a void. It would be change description. Here we would take in a new description. And we would assign the description to this description. It's new description. Okay, not really that. So it would be like that. Of course, also here after validation. So first we will implement later some validation. Okay, and then we would also have, I don't think that we would need anything else here right now, except maybe modifying the entire faculty, which would mean modifying the both the name and the last name, because for the list of departments we would expose, I don't know, if you want to remove all departments, maybe we can implement also a behavior that will remove all the departments. And here let's make it this public void. Here it would be edit faculty. So in this case we would need a string for the new name, a string for the new description, and then we would simply assign the properties. And so that should be it. So right now that I said about if we need to really clear the entire list, we could simply expose this behavior in this faculty class, and it would say public. It wouldn't return anything, but I wouldn't implement this method here, but write a little bit up where we have this remove department just right after this remove department. So it would be a public void clear departments. Here we would actually don't need any incoming parameter, but what we could do is simply departments dot clear, and I guess that this should clear the list. So the list will remain basically with 0 elements. This will remove everything from that list. So yeah, I guess that right now we have implemented also this type of behavior. So is it just a little bit clearer right now why we do this, or why we can simply, when we edit or change the description, when we have an entity, we just can assign the new values to the properties, but when we have value objects like we have in department, as per the domain driven design theory, we don't just modify the properties, but whenever we need to modify a certain value object, we just return a new one. So each time we need to modify something for one department, we just modify the object. And if you have concerns that, okay, what happens when you write this to the database? Well, since it doesn't have any ID, we will see how this will work with Entity Framework Core, because we can use owned types to map value objects to a database schema. But in that case, basically, the ID that the department has is only for the database reference, and it won't basically count. So each time you change it, if it has the exact same values, or it will only change the values basically for that specific department and nothing else. So yeah, that's how we did that. Good. I see there is no other question here, so let's go just a little bit to so faculty. I guess we are done for now with the faculty. If you have more ideas with behavior that we can implement for the faculty, just let me know. But in this case, we can just simply go and say public faculty private set. Because once again, each user, no matter if it is a student or a teacher, it will belong to a certain faculty. So this is why we need this faculty. Okay, and then let's try to think further. What other another thing that we might need? So the faculty has already a list of department, meaning that all the faculties or all the departments that belong to the faculty. But right now, I guess that I don't know, a student can belong to a certain department. Maybe, I don't know. What do you say? Can maybe a student belong to a certain department? Because students can maybe even belong to different departments in some ways. They could have classes, one class from one department, the other optional class from the other department. So yeah, until we know better that we need this, we will just keep that. But another functionality that that the student would have, or yeah, but the teacher wouldn't necessarily have it. But then we can we can only take care of this property if the user type is student. And in this case, what I would like to say is that we could simply also add something like public. I would say, let's make it first now string and now class. What do I mean with that? So I mean that each student actually belongs to a class. A class is usually defined by a group of students that starts the school basically in the same year and end it at the same year. They are known actually as a class. So a class is actually something that we would also, I guess, have to model here in our application, so that we don't use just a simple string. So we would need a class. Of course, we have to create it first. And a class, it's actually I guess it should be a value object, because it doesn't really have to have an ID, but it needs to have certain properties that all must be equal in order to say that these two classes are equal. So let's go on and in this user aggregate folder create a new class. And this class I would well, that's a strange name, because I will also call it class. That's maybe not optimal, but I don't have a better name right now. And this class, I guess, as I said, it would be a value object. Or I don't know, maybe we should be able to identify a class by ID. So is a class identified by an ID, or is a class or identifiable only by the value of the properties? And I guess that a class would be something that that could get just a little bit more complex that I might think of right now. And if it becomes more complex, that could be a sign that it should actually be an entity. Any idea if this class should be an entity or a value object? I'm not really sure. Let's for now maybe make it an entity, and I have a different reason for it. And this is here one point where basically .NET and or all the tooling that we have will pose us some problems if we want to go fully domain-driven design, because according to the DDD principles, when we model our domain, we really shouldn't care about anything else, about all the other layers. So we don't really need to care about databases, we don't really need to care about the infrastructure, but in the end we know that we will have to implement a database and will most probably have Entity Framework Core. And the problem is that in this class, since it would be a more complex class in the end, with several properties and behavior, we would have other properties on that class that will be probably value types. And in that case, this class should be basically an entity that owns the value type that belong to that certain class. So yeah, let's make it an entity. Let's make it an entity for now. Once again, one thing that you will notice if you work on a real domain-driven design project is that even in those cases, the requirements will be far more clearer than what we have right now, because basically we define our functionality on the way. So we don't have really a list of requirements that we have to implement. We just have to think about what we want to have in our application. But you will see that in all domain-driven design projects, you will do a lot of refactoring and changes, because working on a certain model, when you are modeling something, you often come to the conclusion that, okay, this should be modeled maybe differently than from what you have started. So I guess we'll start right now with having this as an entity, and then if we notice at a certain point that the class might actually be a value object, then we'll change it to be a value object. So for now, if it is an entity, what we need is a constructor. Sorry. So we would need a constructor, and in this constructor we would need at least an ID that we will then pass to the base class, and it would be the ID. Let's also create the regions. And this would be constructors and properties, and let's end the region here. Okay, let's see if there are any other questions. No, there are no questions so far. So as said, a class, the way that we think about it in our social network application, is actually a bunch of students that are grouped together by a series of very specific properties that actually have to match in order to define a class. So first, each class has a starting year, date, time. Let's make it date time for now. Maybe later we'll change to use the no.time library. In that case, we'll have to think about if we will do it as an instant or maybe something different. But for now, let's have it as a date time. It would be starting year, get private set. Of course, it's a date time, but we might always only read the year from this date time. So right now I don't bother a lot about this type of things, but if you have any other ideas, then just please let me know. Maybe your ideas are better. We would have an ending year, because each class starts a certain year and ends a certain other year. And for instance, for students that really don't end in the year that they are supposed to end, they basically are moved to a different class that is basically 1 year back, let's say. And then a class, if we think that in a faculty, let's see that right now we start a new university year. And then in a faculty, we might have different departments, and in each department we have a bunch of students that are starting their first year. So we have to model this type of thing and to define the exact class. So in this case, what we would also need to do, we would say that a class would also belong to a certain faculty. Get private set. We will also say that a class public should belong to a certain department. So private set again, of course. And again, within one department, we can have a bunch of students that start their bachelor, but we have another bunch of students that in the same year they start their master's degrees. So in this case, maybe we need also to take into consideration the degree that the class is starting in order to be able to really model this idea of class. So yeah, I guess in that case we might need another class that would be called a degree. But actually in this case, I think that the degree can also be an enumeration, because actually that should be it. So let's add a new class here. Let's call it degree. It will be public, and it would inherit enumeration, our enumeration base class. Of course, we have to also reference or add the using statement to our shared kernel where we have defined our base types. And then what we have here is once again a constructor that will be private. And here we would need to take an int value and a string description. And we don't really need to do anything here in this constructor at all, but we need to pass these values to the base class. So we just pass them. So in this case, we can simply say, as we did in all our other enumerations, we create then fields, static fields, public, static, read-only, and in this case we would get exactly the same behavior that we have on default enums in C#. And we have a first one that it would be, I don't know, bachelor, and that would be a new degree. And let's pass in 0 and how should be this called? I think the official name is bachelor's degree, so it's the genitive. And then public static read-only degree, it should be, I don't know, master, new degree, and here we have in this case it would be 1, so we don't assign also value. And here it would be, as the descriptions, a master's degree. And then we would have a public static read-only degree, and it would be doctorate, and it would be new degree. Let's make it here 2 and call it a doctorate. And actually we have also postdoctorate. Let's also have that public static read-only degree, new degree, and in this case it would have the value 3, and it would be a post research. Okay, should be fine. And right now we have a degree, so we can go back to our user, and here we have a class. Of course, sorry, we have to go to our class back. So right now we can add the degree here. So public degree get and private set, and yeah, so basically right now we can uniquely identify a class. So a certain class can only belong to one faculty, one department, and one degree at a certain time. So we shouldn't have duplicates here in this case. But I guess this would be also an invariant that we will have to take care of at the aggregate. So when we talk about the entire user aggregate, but we'll think about this just a little bit later. And however, one other thing that a class might probably need to have, and that we will also need to model here, is a list of users, but more precisely, basically what we will need here is a list of students. And as we work with lists, it's the same thing that that we did. I guess in the faculty, we will expose this this students list as an property of type IEnumerable, and we will have a backing field that would be a list, and that we can then basically manipulate the way we want. So let's go back here to this class, and let's create here, it would be public IEnumerable of user, and here it will be called students, and here it would be get no, actually no, it would be, we will implement the getter but no setter, so it would be get, and it would return students. Of course we don't have this students field so far, but we will create it. Let's do it here just above the constructor, and it would be a private list of user, and it would be called students, and that should do it for now. Of course we have to also pluralize this, and yeah, that's basically it. And now what we need to do is basically to create the factories for this class. So let's add a new region. Let's call it factories, as we always did. Okay, just remember that I didn't check the chat. So is there anything else here? No, I don't see anything else in the chat right now. Okay, so we have here the factories, and what we would need here is, of course, a factory method that would create us a new class. So let's make it a public static. It will return a class. We'll call it create, and then see what we need to pass in as incoming parameters. We would need, of course, the ID. So it would be of type GeoID. We would need of type the starting year, date, time, starting year. Then we would need a date, time, that would be ending year. What we would need then, we would need a faculty. Let's go on different line. What we would need a department. We would need a degree, and then we would need an IEnumerable of user, and this will be called students. And this is actually the only one that can be default or can have a null, meaning that basically right now, once again, callers of this factory method are now obliged, so they don't need to also provide a students list if this is a default parameter, but all the others are information that we need. So we really can't create a class without having a starting year, an ending year, the faculty, the department, and the degree. So these are type of information that that we really need. Now what we can do here is in this factory method, let me check once again the chat if we have any other questions. No, there is no question so far. So here in this factory method, what we can implement here is also some very basic validation right now, because there are some things that are very obvious from my point of view. So here, for instance, if what we can do here is say that if starting year, so the starting year cannot be less than ending year. So if the starting year is smaller, then we would right now throw a new argument exception. Starting year can't be less than the ending year. Okay, so this is the first validation that we did here, and if we pass this if statement, so if we don't throw the error, in that case what I would say is that we can do, or maybe we can even try that even here, var new class equals new class. And the reason, a very nice thing here, I can name my variable class, because class is a keyword in .NET, so I can't use it as a variable name. So instead I have to name it a new class, and this would be a new class, and I would have to pass in the ID, and right now everything should be fine. Let's maybe also to not have this red squiggly line return the new class, and all the logic will implement further. So then the next thing that we would say is that the new class, but actually we can do this differently. So we don't instantiate the object here, we instantiate the object after this if statement, and if everything is correct, in this case we just will need to also provide here date time starting year, date time ending year, and here of course we will then assign these values, and the ending year would be equal to the value that we get here, but it's with small e. So yeah, that should be okay. Maybe it's a typo, ending year, yes, it is a typo, and right now it should be fine. And in this case what we can do is we can simply say here var new class equals new class, and we just pass in this case the ID, the starting year because we have already validated it, and the ending year. Okay, let's also give it a little bit of space. Now the next thing that we can do is also we can pass in the faculty. I think right now about something that because what we need to do here at this class, we would basically also need to do a validation of the department. What does this actually mean? We need to make sure, because we cannot have a class that I don't know, belongs to faculty X, but then have the department that belongs to faculty Y. So we would need to make a very basic validation about the departments here. But the idea is that validating if a certain department belongs to a faculty or not is something that we would have to implement in the faculty class, because this is a behavior that is specifically specific for this faculty. So it's behavior that we have to basically do there. But before we go to actually the faculty, but actually it's right now that we have to go to the faculty. So yeah, let's go to the faculty, and in this faculty class, what we will do is we will implement another method, a behavior that should basically validate a department. So we are here at the faculty, we have a list of departments, and we will implement a method that would validate this we would basically receive a department as an incoming parameter, and it will validate it. So meaning that it will probably return true if the department is part of the list, and it will return false if the department is not a part of that list. So in that case, let's make it public. It will return bool validate department, and maybe validate department is not a good name because it's clearly not a very specific. Maybe it would be department but no, because it should be a verb. Oh, how should we name that? Do you have any idea how we should name this method? Maybe how we should name this method? So how should we name this method? It's not it's validation is too broad. Here we need or what we want to achieve is validate a very specific thing, and this is to make sure that a certain department that we take in as an incoming parameter belongs to this faculty or not, or if it is in that list of departments of the faculty or not. And here we can say we can maybe say here belongs to faculty, and what we need here is department as an incoming parameter. And then what we can do further is what we would need to basically do is try to see if that department is present in this list of departments that we have here. So in this case, what we would need to do is var find the department equals departments dot first or default, and then we specify the department, and the condition is that the department that we are looking for should be equal to the department that we get as an incoming parameter. And here it would be very simple. If first find department, so if find department equals null, so if we didn't find anything, then we will return false, and then in any other case we will return true. So that is basically the very basic validation that we are doing right now at department at the faculty level. So in this case we can go right now back to this class, and before we need to validate the department, and here we get this this faculty, and I guess that the faculty is something that we can already add to this new class. So new class dot faculty equals faculty. The name new class does not exist. Of course, I have a typo there, and right now it should be okay. And right now what I want to do in this factory method is to validate that the department that the caller gives me here as an incoming parameter does really belong to the faculty. And in this case we can have var belongs to faculty, and in this case we will just call that method new class dot faculty, and it is this belongs to faculty. We just created this method and we pass in the department. And then we can also have a simple if, and if we see that if belongs to faculty, actually we will do the reverse. So if it doesn't belong to the faculty, then we will throw right now a new argument exception. As said, we will come back to these exceptions and we will implement a better pattern to handle inconsistencies in our applications. But for now, we'll just use these exceptions for brevity. And here it would be the message that provided department doesn't belong to the specified faculty. Okay, and then if this check goes through, in that case we will have the new class dot department. Then we can simply assign the department to it, but it is with a small letter. Okay, then what else do we have? We have the degree, and I guess that for the degree we don't really need to do any very fancy validation, because it's basically just an enumeration. So it would be new class dot degree equals degree. However, one thing that we have right now to validate a little bit is this incoming default parameter that could be null. And if it is null, then we want to create an empty list of user. But here we also need to do some validations, because we would have to validate if all the users in this list, assuming that we will get a list that also has some elements. So we'll have to validate that all the users in this list are of type student. So we would need to implement also a validation for that one, and this is a validation that we will have to implement right now, because it is something that could bring our entire aggregate into an inconsistent state. And of course this is not something that we want, and we want to avoid. Okay, I would like to take a short break, if that's okay also for you. I guess it will be a 5 minutes break, and then I'll be back and we'll continue to implement this. Now I guess the stream today will be maybe just a little bit longer, because I think that I want to finish this user aggregate, create also the factory methods for the user, and basically finish everything off, so that we can next time concentrate on something else, and maybe working on a post aggregate, because users should be able to post different things on this social network. So yeah, I'll be on a very short break, 5 minutes, I promise, and then I'll be back and we'll continue to work on this user aggregate. So please stand by, as we'll resume just in a few minutes. It really won't take very long. So we are back. I promised you it wouldn't take long, so it didn't take long. So let's maybe continue right now with what. So we left off basically at this idea that we want right now to add this list of user which should contain only students. So in this case, we should also validate that all the students in the list or that all users in the list are really students. And I guess that the best place to do this kind of validation is this class entity, because it's something that well belongs, or it defines when a class is valid or not. And the class is valid only if all the users in this list are students. So in this case, this is a type of behavior that or validation that needs to be done at this class level. So what I would do here is I would add another region, and let's call it private methods, and let's call it end region. And here what we would do is I don't know, maybe private how should we call it? It will need to return a bool, I guess, right now. So that would be the easiest way to really achieve this. So it will return a bool, but let's name it validate or maybe ensure users are students. What we would need to take in here is an is maybe a list or an IEnumerable of user, and it would be called students. And then what we could do here is simply, I don't know, students. Can we do for each here in this IEnumerable? I guess no, that is only for the list. So what we can do is maybe the easiest way for to proceed is for let's implement a for loop. I guess it's a long time since I've implemented a for loop. So it's for int I equals 0, and we go with I unless it is less than students dot count, and then I plus plus. So we increase, and here if but actually I guess it's better, it's easier to have a for each. And here we make it for each var student in students, and if, and we say here if student dot not username but type. So if student type is not equal to user type dot student, in that case we simply return false. And when we are done with this for each, if we didn't return false, then we can simply return true. And I guess that this would be the basic validation. So in this case we can go back to the factory, and here we can var is student list valid equals ensure users. Of course this can be a static, we don't really need an object reference. Ensure users are students, and we just pass in this students IEnumerable that we get. How is this? Ensure users are students. Maybe I did a typo, and of course that would be students. Now what we need to do is we also have to kind of check for null, because if the list is null, then we can simply return false. If students equals null, so if it is not a list, then we return false, because, well, there is no real user there. And there is another thing that we should take into consideration. If students count equals 0, in that case we will also return a false. And what method group and int. Okay, good. And here we ensure that that students is valid. However, if we can then put here an if. Yes, and we can put here an if. I would say we can put an if, and here we say if is a student list valid. So if the student list is valid, then we can say that new class underscore students equals students. Students to list, of course, because we have to transform this enumerable to a list, because our private field is of type list. And then else, what we can do is simply say that return, no, not return here, but in that case new class dot students equals new list of user. But here I guess we need to put this in an explicit else statement. So it would be else, and I guess then this is correct, but not students, but I want the private field instead. Okay, so if the users are validated, then what we can do is do this. But right now I just noticed that it's a very simple if else. So we can do a ternary, or we can use a ternary operator. So it would be new class dot students equals and is student valid. If it is valid, then we will use the students to list. Else, what we will do is we will simply create a new list of user. And in this case, we can just simply get rid of this entire line of code. And okay, if is student valid, because there is no implicit conversion between method group and of course, because it's student to list, the to list is a method. So yeah, now it should work. So right now what we have, we know that we also have some valid students. And if the list is null, then we will probably assign a new list of user to it. So that's basically it. And then we can return this this class. So that's actually the behavior that we right now have in this class. One other type of behavior that we might need to do here on this class is that we want to add a new student to the class. So this is something that we would surely need. So in that case, let's create a new region, and it would be region, let's call it public methods and region. And here let's say, for instance, that public it would be void, so we don't really need to return anything from it, but it would be add student to class, what we would need to have here is a user as an incoming parameter. We would also have to do a validation, and we say that if user equals so if user.type, so if the type of this user equals user type dot student, so in that case basically we will add to the students list, students add, and we will add this user. But let's also name it student, just to be more explicit, and so that all consumers know exactly what we actually, or what they actually have to type in. So it's student.add student. So we add a student. So that should do it for now, I guess. Okay, so let's then go just a step further. So I guess that we are done with this class. Let's go back to user, and we have this this user. We have this property, so we have implemented all the behavior for this property. Right now, what the user could also have is a public a phone number, but let's make the phone number right now a string. We will probably change it to a default type, or we will change it to a custom type maybe just a little bit later. And then each student would also probably need an email address, and the email address is also something that we will probably need to implement as a value object, because the email address itself is very specific, I would say. So yeah, let's implement it. Let's implement the email address as a value object. What did I do here? Okay, so we are still at the user aggregate. Let's add a new class, and this new class will be called email address. Although now I'm thinking public class, it would inherit a value object. This would for sure be a value object. And now I think about an email address. I guess it's still the same thing. It's an email. It's simply an email address, no matter where in the application we will actually use it. So maybe we can do that. We can implement it in the shared kernel, because as said, once again, an email address will be an email address. So if we have different bounded contexts that maybe work with users, of course the properties of the users could be different from each bounded context to the other, but the email address is always an email address, so it will be throughout the application the exact same thing. So yeah, let's maybe do that. Let's go. Let's basically delete this email address from here, this class that we just created. We don't need it, and we'll go over to the shared kernel types, and we'll create the email address here. As said, because an email address would be actually exactly the same throughout the application, no matter in which bounded context, an email address will always be an email address. And it would be a value object, of course, and then of course it would have to implement the get atomic values method. Let's do the implementation to get rid of this red squiggly line that I really don't like a lot. And what we would need here is we would probably need a constructor. Let's make it private, but let's call CTOR and press tab. Let's make it private. And the email address, basically we don't do anything right now in the email address itself, but we would have some properties. I don't think I would add regions here, because we won't have that many properties and behavior. So right now what we can have here is a property. So an email address would have an email name, It's still private set, and it would have a domain, and here it would be public string domain get private set. Of course, we would also here need to make a validation that the domain string is really or does really represent a domain, but I think we won't bother with it right now. What we will do is here simply have a factory method that would be public static email address. So we would need to pass into this factory method a string that represents the email name and a string that represents the domain name. But let's make it or just domain, not domain name. Let's make it shorter. So it needs to represent the domain, and here we can just simply for now return new email address, and let's use an object initializer here. So it would be email name, would be the email name that we just received, and but of course we don't need to use semicolon here, but instead we need to use comma, and it would be the domain would be equal to the domain, and that should basically do it. I still get an error here, so return new email address. Of course we didn't give it a name. It's a factory name. It's a factory method, so we'll simply call it create, and yeah, we just return that. And probably what we need to do here is okay, implement this this get atomic values, and here we would have a yield return email name, and we would have a yield return domain. One other thing that I would like to do is to override the toString method, public override string, and that's it. And what we want to return here is basically the concatenation of the email name and the domain. So we will simply use maybe a string concat, and we will specify the email name, but we will also need to add the @ sign, so we will have to do that, and then we would specify the third string, which would be the domain. And in this case it would simply concatenate all this type of strings, and it will return just a new string that will represent the entire email address. So yeah, right now I guess that we have an email address, so we can go back to the user and implement it as a property. So public email address, let's call it email get private set, and that would be it. Now right now there are other things that we have to take into considerations about a user, and this is maybe, I don't know, a user maybe needs to have a list of colleagues, and colleagues would mean that if the user is student, then his colleagues would be other students, but if the user is a teacher, then its colleagues would be other teachers. And then we would have also users should be able to make a friend request. So in this case we should also keep a list of all the users that a certain user has as a friend, and then maybe also contain or have a list of pending friend requests, or requests that were basically sent to that user, to that specific user instance, and yeah, but that they are not yet responded. And when a user accepts a friend request, then that request should be removed from the pending requests, and the user should be added to the friends list. So we have to implement this idea of colleagues of friends, and then the idea of a friend request I would get, and all of this would be basically lists. So this means that what we will do is that we will implement them as IEnumerable. So we would have here a public IEnumerable of user, and in this case it would be let's how should we maybe call it? Let's call it colleagues, and we'll implement this this property with a getter, and it will return colleagues. Of course, this is a field that we don't have yet, but let's add it right now. So it would be a private. It would be a list of user, and it would be called colleagues. Sorry. And then okay, what is the problem here? It's returned. Sorry, return colleagues. So right now it should be okay. Then we would have here another IEnumerable, public IEnumerable of user, and this would represent the friends, and we would also have to implement the getter, and it will return a private field. So it will return friends. Of course, we would also have to add this field, so it would be a private list of user, and let's make it friends. And then what we need to do is the idea of a friend request. But to model a friend request, I guess we would need a separate class that would most probably be a value object. So let's go on and add a new class here. So add new class. This would be a friend request, and as I said, this would be a value object. So this is why we will put a public friend request, and it would inherit value object, which is okay. Then of course you would have to implement the override of the abstract method get atomic values. We'll implement it shortly, but not just now. And actually what we would need here also, let's have a private constructor. Let's make it private. I don't think that we actually need any type of incoming parameters right now. The whole idea about a friend request, to model a friend request, it's not really difficult. We would have a public user that would be from get set, get private set, and then it would be a public user to get private set. But now and it would be we would need maybe to keep track about when this friend request was sent. So it would be public date time for now, date sent. So when was the friend request sent? So it will be private set. However, right now, but I noticed the problem that that we might have, and the problem right now is that we have user as an aggregate root, and here we have basically properties that are of type user. So this is something like, so it seems that it's a little bit circular, and that's for sure not okay for domain-driven design, or according to domain-driven design principles, and not even to programming best practices at all. So in this case, I guess what we can do, however, is simply, instead of having this user, this property, instead of being of type user, it should be of type GUID, because what we would need is actually the GUID, the ID of the user that sends the request, and in this case we just would need the GUID of the user towards which this request is actually sent. We don't really need the entire user record with all the properties and so on. So just the ID is basically enough to represent a friend request. And in this case here, in this override, in this get atomic values, we would just have to yield return from, yield return to, and yield return date sent. So those are the properties that we take into consideration for value equality. So let's go then further. The only thing that we still need is a factory method here right now. It would be a public static. It would return a friend request. Actually, what we would need here is the ID of the user that makes that request, GUID from, GUID to. We need the to field, and actually that's all that we need right now, because the date is something that we'll compute ourselves in this class. So it's not something that the consumers would simply have to specify here as an argument. So what we can do here is simply return new friend request. Let's also here use an object initializer, and let's say that to would be or from, let's start with from, would be equal from, to would be equal to, and then date sent equals date time. Let's make it UTC. I always want to keep my dates in UTC and then compute, if necessary, then compute. Of course, we need to give a name to this factory, and it is create. And right now everything should be fine, except it is not, because I have put a semicolon here, and of course we don't really need a semicolon. And I don't know. Okay, no, I don't want to build it right now. I know that that I might have some errors, because I'm not done yet with everything that I want to do. So right now I have a friend request, the basic model of a friend request. So I can go back to this user, and but where does it? Of course, here it's base at degree. Yeah, I didn't even know that I have that error. So it's good that I actually saw it. Good. So right now we would have on public I enumerable of a friend request in this case, and it would be pending requests, maybe pending friend requests, and we will implement the getter, and it will simply return a private field that would be called pending friend requests. Of course, we don't have this this field so far, so let's go and add it. So it would be a private list of friend requests, and it would be pending friend requests. That should do it for now. So yeah, right now we don't have this error anymore, which is very fine for now. So I guess that right now for things that we need as properties, at least, I think we are basically fine. So what we would need to do next, I guess, would be just to go on and create a factory method for that. I guess we would need it. But then here in this factory method, we will also need to add a lot of validations, because we would have to check for friend requests. We would have to do checks for these colleagues, because if the user type is a student, then all the users in the list that we will receive should be also students. And if basically the user is a teacher, then all the users in his colleagues should be also of type teacher. So this is one validation that we would have to do. Then with pending friend requests, we would have to add some behavior to it to exactly define what actually a pending friend request is, and what we should implement, or how we should handle the scenario when a specific user accepts a friend request. So these are a lot of things that we still have to implement, and I think I'm a little bit tired for now, so I guess that's it for today. But we'll continue next Wednesday, or maybe if you want, maybe we can do also an episode during the weekend. But at least you can be sure that next Wednesday we will continue with a new episode from this Building a Social Network from Scratch using domain-driven design principles and patterns. So this being said, thank you very much for watching. Thank you very much for all the questions that you asked in the chat. It was really important for me to get your feedback. It really means that you're interested in what we are doing here, because we are doing it together. We are all learning at the same time. So once again, thank you very, very much for it. Please don't forget to follow my channel to just stay updated whenever I go online and stream. Also, on the channel you would find a list of other social networks where I am, or where you can find me. Basically, I also have a YouTube channel, a blog, I have a Facebook page, a Twitter page, and so on. And especially, please don't forget to check out the YouTube page, since I have a lot of content there, and I'm still creating content specifically for and only for the YouTube page, which are shorter videos on topics, of course, related mostly to .NET and Microsoft Azure. So I think that you'll probably find some useful stuff there too. And yeah, just let's just keep in touch, and I hope to see you back next time. We will continue to work on our social network. Thank you very much once again, and have a good night. Bye.